I hope all of you are doing good. Let's start today's chapter, Visualizing Solid Shapes. After reading this chapter, you will be able to know about all these topics. Okay, so let's get started. Introduction. We have studied about two-dimensional figures such as rectangle, square, trapezium, etc. These are called plane figures. They have only two measurements like length and breadth. Okay, which you already know that. Now, definitions of solids. Objects having fixed shape and size occupy fixed space and are called solids. Solids occur in various geometrical shapes. These shapes are known as three-dimensional figures. We have already studied about some three-dimensional shapes such as cubes, cuboids, cylinders and cones in class 7. These are all single shapes. However, in our daily life, we come across many 3D shapes which are a combination of different 3D shapes. For example, let us look at the following object. See, have you seen this? You have also eaten this, right? Softy ice cream. So this is the combination of cone and hemisphere. Okay, cylindrical shell. Okay, this is a tin. This is a toy. This is a combination of a hemisphere. This is the hemisphere and this is cone. Okay, this is a cake. This is a combination of cylinders. As you can see, 1, 2, 3 cylinders are there. Okay. Views of 3D shapes. If three-dimensional objects are viewed from different positions, they look different. So the same 3D objects can be drawn from different perspectives. For example, a small heart can have many different views. See this? Okay. Similarly, a jug can have the following views, right? Even these 3D shapes can have many other views when seen from some other position. Let us see different views of a cuboidal box. Okay, these are the different views of the cuboidal box when seen from different position. Okay, if different cubes are joined in definite manner, they can have different views from different positions like this. Okay. Exercise 10.1. For each of the given solids, draw a top view, front view and a different side view from other position. Okay, so there are figures given to you. You have to draw top view. Means if you look this particular object, that is a bottle, from top, what will be the view? Okay, then you will also draw a front view and a side view also. Okay. Mapping. In lower classes, you have already dealt with maps in history and geography. In history, you located a particular place where some important event had occurred long back. In geography, you have been asked to locate particular country, state, city, river or mountain, etc. on a map. You have traced routes of rivers, roads, railway lines and many others. Difference of picture and map. Maps are different from pictures. How do we read a map? What information does a map have and what it doesn't have? Here a picture and map of a house is given. See, this is the picture but this is the map. Okay. Now let's find out what is the difference between picture and map. Okay. In a picture, we try to show all the details, we attempt to represent reality. But in map depict only the locations of object with respect to other objects. Okay. Number 2, from different position of observer, details and descriptions of picture are completely different. On the other hand, map remains same irrespective of the position of the observers, right? It doesn't matter where the observer is. And number 3, perspective is very important. Objects which are closer to the observer are shown bigger as those that are farther away as shown here. Okay. And in map, perspective is not relevant for a map. The objects which are closer to the observer are shown of the same size as those that are farther away as shown here, right? Characteristics of map. A. Maps depict the location of any place or object with respect to the other places or objects. B. Different symbols are used to depict the places or objects. Symbols and mentioning of distances help us to read the map. C. Scale is very important. It is fixed for a particular map. It reduces the real distances proportionally to distances shown in map on paper. D. Scale vary from map to map but not within a map. Example, in map of city or state, country, scales will be different. 1 centimeter or 1 millimeter of a space in the map shows the distance of either 1 kilometer, 10 kilometer or 100 kilometer. E. When the maps are drawn of same size, scales and distances in two maps will vary. Space of 1 centimeter in the map to city will represent smaller distance as compared to the distance in map of world. Okay. Exercise 10.2. Here is a map of a city given to you. Okay. Look at this map and there are questions asked. You have to answer these questions. Okay. Polyhedrons, faces, edges, vertices. Each of the solids is made up of polygonal regions which are called faces. These faces meet at line segments which are called edges. Edges meet at points which are called vertices. The solids made up of polygons, triangles, quadrilaterals as faces, line segments as edges and points as vertices are called polyhedrons. Okay. Select the polyhedrons out of the following figures. Okay. So you have to select the polyhedrons out of these figures. What do you mean by polyhedrons? As I told you, they are made up of polygons, triangles, equilaterals, okay, as faces, line segments and edges. So see, 1, 2, 3, these are the polyhedrons. Okay, no more. Non-polyhedrons have curved surface, like in this case, in these two figures. Okay, example, sphere, hemisphere, cylinder, cone, etc. Polyhedron have flat polygonal faces, example, pyramid, prism, etc. Okay. Okay, here also you have to select which out of them are polyhedron. Obviously this one and this one. Okay. No more. Concept of convex and non-convex polyhedrons is same as the concept of convex and non-convex polygons. Okay. Now you can easily do this. You have to select the convex and non-convex polyhedrons out of the following. Okay. Now regular and non-regular polyhedron. A polyhedron is said to be regular if its faces are regular polygons. 2. Lateral faces are congruent, and number 3, vertices are formed by the same number of faces. Okay. No more. Is it a regular polyhedron and why? This one. Answer, yes. Its faces are polygons. Lateral faces are congruent. Vertices are formed by the same number of faces. Is it a non-regular polyhedron and why? Yes, all the sides are congruent, but vertices are formed by different number of faces. 3 faces are meeting at vertex P, but 4 faces are meeting at vertex Q. You can make 6 more figures, 3 regular polyhedrons and 3 non-regular polyhedrons, right? No more. There are 2 main important types of polyhedron. A, prism, 2, pyramid. Prism. If in polyhedron base and top are congruent polygons and lateral faces are either parallelograms or squares or rectangles, then they are called prism. Pyramids. If base is a polygon of any number of sides, lateral surfaces are triangles with common vertex, then they are called pyramids. Okay. No more. A prism or pyramid is named after its base. Example, if base is pentagonal, then prism or pyramid will be called pentagonal prism and pentagonal prism respectively, and so on. Okay, this is pentagonal prism and this is pentagonal pyramid. Okay. Now views of 3D shapes. We have studied about faces, edges and vertices of different figures. The relation among faces, edges and vertices is known as Euler's formula. Euler's formula is as follows. F plus V minus E is equals to 2, where F is number of faces, V is number of vertices and E is number of edges. Okay, let's do the example. For the following figures, verify the Euler's formula. Okay, A is hexagonal pyramid. Okay, so in hexagonal pyramid there are number of faces 7, number of vertices 7 and number of edges 12. Okay, let's verify this. What is the Euler's formula? This is the Euler's formula. F plus V minus E is equals to 2. Now let's put all the values. 7 plus 7 and then you have this minus 12. Okay, is equals to 2. 7 plus 7, 14 minus 2 is equals to 2. 14 minus 12 is 2 is equals to 2. LHS is equals to RHS. That means this formula is verified. Which formula? Euler's formula. Okay. B, cube. Okay. Number of faces 6, number of vertices 8 and number of edges 12. So the formula is F plus V minus E is equals to 2. Okay, now let's put the value. 6 plus 8 minus 12 is equals to 2. 14 minus 12 is equals to 2. 2 is equals to 2. LHS is equals to RHS. Hence, formula is verified. Okay. Example 2, using Euler's formula, find in the missing. Okay. Here, faces are not given, vertices and edges are given. Okay. So, let's do it. Okay. See, this is the formula. Okay. Faces, we have to find out, vertices are 6, edges are 12. Okay. So, face F plus vertices 6 plus, not plus, minus 12 is equals to 2. F 12 minus 6 is minus 6 is equals to 2. So, F is equals to 2, then we will transpose it to the right hand side, plus 6. So, value of F is 8. That means there are 8 faces. Okay. Similarly, you will do B part also, students, and now you will do practice of this chapter and the remaining questions. Okay.